Why does the Cambrian matter 540 million years later? You might wonder, why spend so much time studying organisms that went extinct hundreds of millions of years ago?
Why does the Cambrian Explosion matter to us today? Over 9 episodes, you've journeyed through the Cambrian Explosion, the most dramatic transformation in the history of life on Earth. You began in the Precambrian stage, watching as oxygen accumulated, genetic tools assembled, and simple organisms like Dickinsonia and Charnia lived peacefully in oceans without predators. You witnessed the explosive moment when predation appeared, triggering the most rapid diversification event ever recorded. Virtually every major animal body plan emerging in just 10 to 25 million years. You met the trilobites, those armored arthropods whose calcite exoskeletons and compound eyes helped them dominate oceans for 270 million years. You encountered Anomalocaris, Earth's first apex predator, with its enormous eyes and powerful grasping appendages. You discovered how eyes evolved from simple light-detecting patches to sophisticated compound and camera eyes, changing predator-prey dynamics forever. You saw shells and armor appear across dozens of lineages simultaneously, as organisms responded to predation pressure with mineralized defenses. The Burgess Shale revealed creatures so bizarre they initially defied classification. Opabinia with 5 eyes, Hallucigenia walking on spines, Wiwaxia covered in scales and spikes. You met Pikaia, the humble chordate ancestor that seemed insignificant in the Cambrian, but carried the body plan that would eventually produce all vertebrates, including you. You explored how Cambrian ecosystems functioned as complex food webs with multiple trophic levels, predator-prey relationships, and ecological principles still governing life today. Now in this final episode of Arc 2, we'll step back and examine the big picture. What does the Cambrian Explosion mean? Why does an event 540 million years ago still matter today? What lessons does it teach about evolution, extinction, adaptation, and the nature of life itself? And how does understanding the Cambrian help us understand ourselves and the world we live in? This is the Cambrian Legacy, the story of how 25 million years of ancient innovation created the blueprint for all animal life on Earth. Here's the answer. Every animal alive today, including you, is built from a Cambrian blueprint. Your body plan, established in the Cambrian. Your eyes, Cambrian innovation. Your backbone evolved from Cambrian notochords. Your arms, legs, fingers, modified from appendages first developed in Cambrian arthropods and their relatives. The Cambrian wasn't just an interesting historical event, it was the foundation. Everything since has been variation, elaboration, and refinement of body plans created during that explosive 25 million year window. But the Cambrian teaches us more than just anatomy. It reveals fundamental truths about how evolution works, why diversity matters, what causes extinctions, and how life responds to crises. Understanding the Cambrian means understanding life itself, its origins, its principles, its potential, and its limits. This is the Cambrian Legacy. The Cambrian Explosion demonstrates several fundamental evolutionary principles still governing life today. Principle 1. Evolutionary radiations follow ecological opportunity. When new ecological opportunities open, empty niches, new resources, reduced competition, evolution accelerates. Life diversifies rapidly, filling available space with countless variations. The Cambrian showed this principle at maximum intensity. Opportunity. Predation created new niches, predators, prey with defenses, scavengers. Response. Explosive diversification into every available niche result. Modern animal phyla established in less than 25 million years. This pattern repeats throughout history. Post-extinction recoveries see rapid diversification, island colonizations, trigger adaptive radiations, new habitats, land, air, fresh water, spark explosive evolution. The Cambrian was the biggest opportunity in history, generating the biggest radiation. Principle 2. Major transitions happen rapidly. Evolution isn't always gradual. Sometimes it accelerates during critical transitions, and the Cambrian was the ultimate transition. From simple soft-bodied organisms to complex armored predators in 25 million years. Geological eye blink, evolutionary lightning. Why so fast? Because selection pressure was intense. Organisms without defenses died immediately. Predators without effective weapons starved. Every generation faced extreme selective pressure. When pressure is weak, evolution can be slow. When pressure is intense, evolution accelerates. Principle 3. Not all innovations succeed. The Cambrian tried thousands of body plan experiments. Most failed. Opabinia, Hallucigenia, Archaeocyathans, and countless others left no descendants. Why did some succeed while others failed? Often not because they were better, but because circumstances favored them. Chordates succeeded partly through luck. They happened to have adaptable body plans when conditions changed. Trilobites succeeded through versatility. Their design worked in many environments. Many bizarre Burgess shale organisms failed despite being perfectly functional. They were simply outcompeted or environmentally unlucky. Evolution isn't about perfection. It's about being good enough in the right place at the right time. Principle 4. Constraints limit. Future evolution. Once a body plan is established, it constrains future possibilities. Arthropods are forever limited by molting. They'll never have continuous growth like vertebrates. Vertebrates are forever limited by internal skeletons. They'll never have the lightweight exoskeletons enabling insect flight mollusks invested in shells early, making active predation difficult, though some, like squids, abandon shells later. The Cambrian established these constraints. Subsequent evolution works within them, elaborating, modifying, but never completely escaping the original design. Principle 5. Ecosystem complexity promotes stability. Cambrian ecosystems started simple and became complex. As complexity increased, ecosystems became more stable, better able to withstand disturbances without collapsing. Why? Because complex ecosystems have functional redundancy, multiple species performing similar roles. If one goes extinct, others compensate. Multiple pathways. Energy can flow through different routes. If one breaks, alternatives exist. Buffering capacity. Diverse systems absorb disturbances better than simple ones. This principle explains why modern conservation focuses on preserving biodiversity. Diverse ecosystems are resilient ecosystems. The Cambrian created an anatomical toolkit that life still uses. Body plans, organs, systems established then, elaborated since. The major body plans. Virtually every major animal body plan appeared in the Cambrian. Arthropod, body plan, segmented body with jointed appendages. External skeleton, exoskeleton, compound eyes, ventral nerve cord. This plan produced insects 1 million plus species, spiders 50,000 plus species, crustaceans 67,000 plus species, the most successful animal design ever. Mollusk body plan, soft body with muscular foot mantle, tissue layer, secreting shell radula, toothed feeding structure, in many groups. Open circulatory system. This plan produced snails, clams, squids, 80,000 plus living species occupying ocean, freshwater, and terrestrial environments. Chordate body plan, notochord or vertebral column dorsal nerve cord, spinal cord, pharyngeal slits or their derivatives, post-anal tail. This plan produced fish, 35,000 plus species, amphibians, reptiles, birds, mammals, including humans. Echinoderm body plan, 5-fold radial symmetry, water vascular system calcite endoskeleton. This plan produced starfish, sea urchins, sea cucumbers, 7,000 plus species. The organs and systems beyond body plans, specific organs traced to the Cambrian. Eyes, compound eyes in arthropods, camera eyes in vertebrates and cephalopods, all Cambrian innovations. Jaws evolved from pharyngeal arches in the Ordovician, but pharyngeal arches originated in Cambrian chordates. Armor and shells. Biomineralization techniques established in Cambrian, same basic chemistry, calcium carbonate, still used today. Appendages. Jointed limbs of arthropods, muscular feet of mollusks, fins of fish, all derived from Cambrian structures. Complex nervous systems. Sophisticated brains processing visual information, coordinating movement, enabling learning, begun in Cambrian predators like Anomalocaris. Evolution didn't invent these anew. It inherited them from the Cambrian and modified them. The Cambrian established behavioral and ecological principles still governing life. Predator-prey dynamics before the Cambrian, no predation. After the Cambrian, predation is universal, shaping every ecosystem. Modern predator-prey relationships, population cycles, arms races, coevolution, all originated in the Cambrian. Competition and niche partitioning. The Cambrian taught life how to share resources through niche differentiation. Different species eating different foods, dietary specialization. Same species active at different times, temporal partitioning. Different species living at different depths or habitats, spatial partitioning. These strategies, pioneered in Cambrian seas, now operate in every ecosystem on Earth. Symbiotic relationships, mutualism, commensalism, parasitism, possibly originated in the Cambrian, though evidence is sparse. By the Ordovician, clear symbioses existed. The Cambrian likely set the stage by creating ecological complexity, where partnerships could be advantageous. Ecological engineering. Cambrian burrowers, filter feeders, and reef builders modified their environments, creating new habitats, altering water chemistry, changing sediment properties. This principle, organisms shaping their environment, remains central to ecology. Beavers dam rivers, earthworms enrich soil, coral reefs create three-dimensional habitats, all following the ecological engineering principle established in the Cambrian. The Cambrian teaches lessons directly applicable to modern conservation challenges. Lesson 1. Biodiversity buffers against extinction. Cambrian ecosystems with higher diversity survive transitions better than low-diversity systems. Why? Because diverse systems have more genetic variation, raw material for adaptation, functional redundancy, species can replace each other, complex food webs, less vulnerable to single-species loss. Modern conservation efforts prioritize biodiversity for these same reasons. Diverse ecosystems are more resilient to climate change, habitat loss, and other threats. Lesson 2. Rapid environmental change causes mass extinctions. The Cambrian-Ordovician transition, though less severe than later mass extinctions, showed that rapid environmental change disproportionately affects specialists, species adapted to narrow conditions, species with limited geographic ranges, organisms with inflexible physiologies. Modern climate change is happening faster than natural Cambrian changes, suggesting current extinction rates may exceed historical norms. Lesson 3. Recovery takes time. After the end Cambrian extinctions, ecosystems took millions of years to fully recover, redeveloping complexity, refilling niches, establishing new equilibria. This suggests modern extinctions won't be quickly reversible. Even if we stop causing damage, recovery will take geological timescales. Lesson 4. Novel innovations can destabilize ecosystems. The Cambrian shows that major innovations, eyes, jaws, armor, can destabilize ecosystems temporarily, creating winners and losers, forcing reorganization. Modern human technology is analogous. A novel innovation, industrial technology, genetic engineering, AI, destabilizing existing systems. Understanding Cambrian transitions helps us anticipate modern disruptions. The Cambrian ended with extinctions. What lessons does this teach? Mass extinctions are inevitable. The Cambrian-Ordovician transition wasn't the worst extinction. Later events, Permian-Triassic, Cretaceous-Paleogene, were more severe. But it showed that even after massive diversification, extinction is inevitable. No species, no body plan, no ecosystem lasts forever. Change is constant, and every lineage eventually goes extinct or evolves into something unrecognizable. Recovery produces different, not identical ecosystems. The Ordovician ecosystems that followed the Cambrian weren't Cambrian ecosystems restored. They were new ecosystems with different dominant groups, different food webs, different ecological structures. This suggests modern ecosystems destroyed by human activity won't be replaceable. Even if we restore habitats, the resulting ecosystems will differ from originals. Survival doesn't mean best, it means lucky and adaptable. Many Cambrian winners, successful, abundant organisms, went extinct. Many losers, rare, seemingly unimpressive organisms like early chordates, survived and eventually dominated. Success is contingent, dependent on unpredictable environmental changes, chance events, historical accidents. The best adapted organism today might be extinct tomorrow if conditions shift unexpectedly. Current status: living in a Cambrian world. We're not separate from the Cambrian legacy, we're part of it. Your body is built from a Cambrian body plan, chordate. You eat food in Cambrian-style food webs, trophic levels, predator-prey. You live in ecosystems structured by Cambrian principles, competition, niche differentiation. Your evolutionary potential is constrained by Cambrian decisions, vertebrate design. The Cambrian isn't ancient history, it's the foundation of the living present. As we close this arc, what are the Cambrian's most important lessons? 1. Life is explosive when given opportunity. The Cambrian shows life's incredible creative potential. Given ecological opportunity and evolutionary time, life generates dazzling diversity. Thousands of body plans, millions of species, endless variations. We live on a planet where evolution works, where complexity emerges spontaneously, where innovation is constant, where possibility is limitless. The Cambrian proved this conclusively. Evolution is contingent, not predictable. If we could rewind the Cambrian and play it again, would the same organisms succeed? Probably not. Small changes, which predator caught which prey, which species happened to be in the right place when an environment changed, could alter outcomes dramatically. This means evolution-specific outcomes aren't inevitable. Humans aren't the inevitable result of evolution. We're one possibility among countless alternatives. In a different Cambrian, chordates might have gone extinct and some other lineage might have eventually developed intelligence. Diversity matters, not just for beauty but for survival. The Cambrian's diversity wasn't decorative, it was functional. High diversity meant more ecological options, more evolutionary potential, more resilience to disturbance. Modern biodiversity loss isn't just aesthetically sad, it's functionally dangerous. We're reducing options, limiting potential, weakening resilience. The Cambrian shows what's possible with high diversity. Modern extinctions show what's lost when diversity declines. Major transitions change everything. The Cambrian was a transition from simple to complex, from passive to active, from individual to ecological. That transition changed life's trajectory forever. We're possibly in another major transition, from purely biological to technological, from single planet to multi-planet, from unconscious to conscious evolution. Understanding past transitions helps navigate present ones. The present contains the past. Every animal alive today carries Cambrian heritage in its body plan, its genes, its ecological relationships. The Cambrian isn't finished, it's ongoing. Every generation elaborates Cambrian themes, modifies Cambrian structures, continues Cambrian experiments. You are the Cambrian's descendant and continuation. Understanding the Cambrian means understanding yourself. The Cambrian explosion established animal diversity in the oceans, but oceans weren't empty. They were filling with life at every level, from the seafloor to the surface. In our next arc, we'll explore what happened after the Cambrian, how life conquered new environments, how plants transformed the earth, how animals followed plants onto land. The Cambrian exploded in the oceans. The next revolution would transform the continents, creating forests, enabling new animal groups, and ultimately producing the complex terrestrial ecosystems we know today. From sea to land, from Cambrian foundations to terrestrial elaborations, the story continues. But before we move forward, take a moment to appreciate what the Cambrian accomplished. In 25 million years, life went from simple, soft-bodied organisms to complex ecosystems with predators, prey, armor, eyes, intelligence, and ecological sophistication, rivaling modern oceans. That's not just impressive, it's one of the most important events in Earth's history. The Cambrian changed everything. Everything since has been elaboration on Cambrian themes. Remember the trilobites who dominated for 270 million years. Remember Anomalocaris, the first apex predator. Remember the strange Burgess shale creatures proving evolution experiments fearlessly. Remember Picaya, the humble ancestor carrying the potential for all vertebrates. These organisms, these innovations, these ecosystems, they're not distant ancient curiosities. They're your heritage, they're your foundation. They're why you exist. The Cambrian explosion was life's greatest gamble, and it paid off spectacularly. You've completed Arc 2 Ocean Awakening, the Cambrian explosion. You've witnessed the Precambrian stage being set, the explosive diversification of body plans, trilobites mastering survival, Anomalocaris pioneering predation, eyes evolving and changing everything, shells and armor triggering arms races, the Burgess Shale preserving incredible detail, early chordates surviving against odds, ecosystems becoming complex and functional, the legacy that still shapes life today, every episode built on the last, revealing how the Cambrian established the modern world's foundations. In Arc 3, we'll leave the oceans and explore the conquest of land. Plants photosynthesizing on continents, arthropods following them ashore, forests creating new opportunities, and animals adapting to terrestrial life. The ocean exploded with life. Now life will explode onto land. The journey continues. This is HistoPrimordia, where history comes alive. Thanks for watching. Subscribe now and join us for the next Arc story.